and Willow. So I'm going to go straight introduce you to Chris Rees and Dr. Willow Smallbone, who work as Leakage Manager and Data Analytics Manager, respectively, at Welsh Water. So their presentation will explore the way in which data is managed and how some of the data science techniques are deployed to help inform the Welsh Water leakage team. Over to you, Chris and Willow, please.
Thank you.
Great, thanks, Pauline. So yeah, if we can have the next slide, that'd be fantastic. Okay, perfect, thank you. And so yeah, hi, I'm Willow, I'm Data Analytics Manager. So I manage the data science team. So I just wanted to start by giving you a bit of an overview of the data team here at Welsh Water. And so we like Yorkshire Water support the entire business. So everyone from the waste side of the business, clean, retail, as well as all the support services, the HR and finance and the like. And so the data team is made up of five sub teams that you can see on the screen here. So starting with data governance, and this team really supports the business in terms of improving data quality. So it's utilising data stewards and data owners in order to try and embed data quality within like everyday work that the business is doing. So rather than the data governance team driving improvements in data quality themselves as quite a small team, it's about empowering the business themselves to improve on that data quality and try and embed more of a data culture within the organisation. And so they measure the success of their work through the data maturity and through various data maturity, very much working in collaboration with business areas. Secondly, then the data engineering teams. This is a team that's pivotal in really all of the work that the data science team do. So it's kind of the underpinning of us being able to access a lot of the data. So it's around developing and populating our enterprise data platform, so our cloud warehouse. But they also manage kind of our interim solutions on premise with our SQL servers. The business intelligence team then are leading our centre of excellence in terms of ensuring that we have a centralised approach to business intelligence as an organisation. So as every business, I think there's a lot of reports out there that kind of have a different use different sources of data and that maybe have different levels of reliability. So the Centre of Excellence is there really to try and encourage kind of the same look and feel for reports that we're pulling together, but also encourage the use of kind of a centralised approach to data and putting that data governance in place and trying to get to one version of the truth kind of approach for reporting. And finally, then the data migration team kind of is there to support the business to move to new systems. So as we move it, just as an example, moving to a new HR system at the moment. And the one that I've missed there is my team, the data science team. So we're kind of a team of colleagues that have got a broad range of skills, and really our focus is on predictive forecasting kind of types of analytics, as well as artificial intelligence, simulation, optimization, and application development. So we've got a really broad range of kind of skills with no two people having the same skill set, but as a whole kind of being able to build that up. And really the idea behind our team is to take a business problem, use data and analytics to be able to provide better insight to the business to help make better data-led decisions. So it's not for us to give an answer, it's for us to be able to provide that information back to the business to enable better decisions to be made. So all of the work that we do are aligned to strategies. So in this instance, we align to the leakage strategy, and we're ensuring that we're delivering to kind of aligning our projects with measures of success. And obviously the kind of the variability of the projects we deliver means that every project kind of needs its own bespoke solution. So if we can move on to the next slide. Just wanted to provide a bit of background really as to where the data team and kind of the journey that it's been on. So it started in 2014 just with one individual kind of managing kind of starting, I guess, data science within Welsh Water. And through just a handful of years, we've kind of built to be a team of 22 across the whole data team, with about half of that being the data science team. And as Yorkshire Water previously mentioned, the importance of the data quality really underpins it all. So although a really small team, it's obviously a pivotal team to ensure that the work that we're doing is of a high standard. And on to the next one. So kind of, I just wanted to talk you through kind of our project life cycle in a little bit more detail. So the way that we work is very much in aligns with kind of how Yorkshire described it, and really that's around kind of the pre-work. So really understanding what that business problem is, scoping that project out, really talking with stakeholders, understanding the business challenge, getting to the root cause of that challenge. Sometimes the challenge that comes to us isn't always kind of the root cause, and sometimes when you start to understand a bit more, you really understand kind of how we can better support. And during that process, obviously understand what benefits the project could bring, and going through all the data protection and kind of information security kind of requirements to ensure that everything we're doing aligns with kind of legally what we're allowed to do. Moving on then into kind of 4-week sprints where we work with business owners to develop minimum viable products of models and user interfaces, gaining feedback as regularly as we possibly can, before then getting to a point where everybody's in agreement that it's kind of fulfilling what we need. And then it kind of goes through the final processes. That final model is built and the user interface is signed off, and we kind of formulate it as a collaborative kind of a deployment plan and understand how we're going to embed. And it's already been alluded to that, you know, that's often when things fall over. We have very similar challenges, and it's all about kind of getting the business involved, kind of them taking ownership of the product rather than us. You know, we can't really instill change within processes that we don't fully know or fully understand, and you know, we have no real, you know, kind of reason to. But it's really important that in this instance the leakage team kind of take that responsibility and run with it and change process that needs to ensure that we can embed this type of work. And finally, and most importantly, really, it's that monitoring and running of the models. So, you know, a model may have started out at 95% accuracy, but through time you start to get data changes, and, you know, COVID being a prime example of that, where it's completely skewed every data set I think that we all hold. And but it's about monitoring that data to see how it's changed and see what impact that has on the model, and picking that model up then to rerun if necessary. Next slide.
Thank you. Can everybody hear me okay?
Yep.
Yeah, great. So thanks for that, Willow. So I'm Chris Rees, I'm the Leakage Strategy Manager at Cymru. I'm going to give a brief introduction to a data project that, through collaboration between the Leakage team and the data science team, we have successfully implemented very recently. So I'll let Willow explain in slightly more detail on the coming slides the tools and techniques used in the delivery of the project. But I just thought I'd give a bit of an overview of, well, this session and where this idea came from. So the idea of this session stemmed from a discussion in the Water UK Leakage Managers Network meeting probably a year ago, and I think it was actually a week before the lockdown started. So I think it was the last time I saw colleagues in a year. So in the world of leakage, we've been practicing data science techniques for many years, and we have complex software systems which have been developed over time. More recently, the quantity of data that we generate is probably growing exponentially from our ever-increasing data sources, installation of network sensors, and that's kind of coincided with the emergence of data science teams within water companies, and also the specialism within the supply chain. So I think this puts us as leakage practitioners in an ideal position to harness the benefits that data science can bring. So I'm sure this photo and the photos on the screen there bear some resemblance to scenes our leakage teams are facing across the east of the UK at least, and it's actually just started snowing here too. This is actually a photograph of a mountain rescue team from North Wales, and a volunteer member of that team, Craig Jowett, one of my colleagues in Welsh Water, working as an analyst in the leakage team when he undertook a rescue over one weekend. You can see in the photograph the planning activity which the team undertook using probability search theory prior to undertaking the rescue, where factors such as age, experience, last known location, and weather are taken into consideration in order to highlight the search route and localization of the missing person. Thankfully, that was a successful rescue, and it got Craig thinking about how similar techniques could be used to help localize a leak. I guess they had an advantage. The casualties are above ground, our pipes are below ground, but we do have a wealth of data and network sensors and an underground network. So Craig submitted an idea, Project Nemo, with the intention to help us localize leaks. So although our coverage of network sensors is increasing, and we'll hear over the course of today and tomorrow about some of the fantastic equipment which is now available to us, we won't get the coverage for some time. So therefore we saw some real benefit in developing this project to help us target reactive leakage breakout. We often use our more experienced leakage technicians who've built up knowledge of areas over many years to respond to these events, even though the leaks are often the easiest to find, really. This is due to the large impact these leaks can have to reported leakage, and also, potentially customer impacting as well. So Project Nemo aims to help equip any technician with a local knowledge to help locate these leaks. That gives us the opportunity to use the most efficient resource then for each instance. As well as this efficiency, it also provides us with the ability to respond to leakage outbreaks events, which most of us have probably seen at the start of January, through the use of resource and teams wider than just the leakage team. In our instance, we've used meter reader technicians quite recently, utilising this technique. So I'll just hand you back to Willow to explain in a bit more detail.
Hi, yeah, could we have the next slide, please? So Chris just gave a nice summary of kind of how Project Nemo came about. So really the current situation was kind of, where are our leaks, like how can we find them quicker, and obviously then be able to resolve those leaks quicker. And with the kind of the proposed solution to be able to kind of identify where a leak is most likely to occur, and then provide an optimized route for us to be able to locate those within a DMA. So next slide, please. There's a whole host of benefits that kind of can be associated with this particular project. Obviously, reduced leakage being kind of a key one, but it's also around kind of the improved productivity and the kind of the feeling that the workforce get from increasing their productivity. Obviously, everybody wants to go out and find one, maybe several leaks every day. And unfortunately, that's not always the case. So the more that we can do to make the team feel more empowered and have all the data that they need to be able to do their job better, and the better and the more engaged you get to make those people. Obviously, in doing that, you're reducing environmental impact and through reduced leakage, but also providing a safer working environment by being able to kind of better plan the route that needs to be taken, and also reduce kind of the locations that an individual may need to go in order for them to be able to find the leak. But really the kind of the pivotal bit of all of this is using that data as best we can, data to enable us to be able to provide better understanding of where the leaks may be, but also to drive investment. So if we know that there's particularly high risk pipes that are almost always predicted to leak when we have a leak in a DMA, well, why don't we invest in those? Why don't we make a kind of more proactive decision to in order to kind of reduce that risk? So we can go into the next slide, please. And this project was kind of broken up into kind of 5 phases. The first phase being a proof of concept phase in collaboration with Cardiff University. So every year we support several students with their MSc dissertations through Cardiff University and University of South Wales. And this was a project that we put forward to Cardiff University in order to support a student with supporting them in collaboration with the leakage team to deliver a model that would identify a leak location. So we provided them with data We provided them with some business knowledge. We provided them with kind of access to the stakeholders to ask questions so they could get a really good understanding. And what this proof of concept showed was that it is possible to use statistics in order to kind of identify where a leak is likely to occur. And this meant that we kind of felt that we could put more resource internally into this project in terms of kind of taking it kind of to a fully fledged project. So high level, this project was broken down into four kind of, I guess, sections to a project. And I'll go into a little bit more detail. But first, we started off by looking at DMA clustering, so understanding similar characteristics for each DMA, predicting the location of a leak, followed by creating a route optimization, and then obviously the user interface. So if we could just go on to the next slide, that would be great. So the first element of this was DMA clustering. So this was the starting point for this project. And really the reason behind this was to understand DMAs and how they were similar based on leakage and pipe characteristics. So we pulled together a whole host of different data sets to understand kind of the similarities between DMAs. And the reason for doing this was rather than building a separate model for every DMA, which would be hugely intensive in terms of compute, we wanted to build a model for each of the groups. So obviously this would massively reduce the number of models that we needed to run, the costs associated with that, but also the time and the compute required in order to do this. So we used clustering algorithms to understand kind of how our DMAs clustered based on, as I say, leakage and pipe characteristics. And the next slide, please. So after we gained a better understanding of kind of the DMAs and how they grouped and their similarities, we were then able to build predictive models. And this predictive model kind of was initially used, well, I say predictive model, several predictive models using various algorithms to understand which one was going to best perform for this particular business problem. So we used a whole array of different statistical algorithms. We spoke with the stakeholders to understand kind of how the analysis was working, to make sure that they were able to take actionable and kind of actions off the back of those models. And some models are quite explainable with it really easy to take actions off, and some are much more complex and kind of more black box, which obviously doesn't make them that useful in terms of being able to take action. So after we found the best algorithm, we went on to the next slide, sorry. We went on to look at route optimization. So as Chris rightly mentioned, there's lots of different kind of ways in terms of kind of optimal search routes and the like that can be used. And this particular example kind of fits quite nicely with the traveling salesperson problem. And this is basically trying to find the shortest route to be able to visit every point on the plot kind of once and return back to base. So it's a really similar problem to how you would imagine a leakage technician would work. They leave home, they go out, they go to various locations in what we hope is an optimal route, and they return back home. So the image on the left shows how you would likely do it if you just went out and just looked. And the image on the right is if we optimize that route and kind of show people the order to go to these points. And the way that we've used this optimization the route optimization is by building in the risk. So out of the predictive model, we get a risk score for every pipe in the DMA. And then the route optimization basically tells you which pipes to go to and what order. So we start on the highest and the medium risk. So those are the ones we send you to first. And then obviously, if you still haven't found them, you start to work down that list towards the low risk. And then the final element of this, if you just go on to the next slide, is the user interface. This is the most important part of the project. It's the bit that kind of overlays everything that's been done. So it's providing the insight that we're providing back to the business in a way that they can understand. So it's provisioning the business with all of the data that they need, so that when a technician goes out and they find out what their route is, they have everything kind of within that application that would allow them to do this. So this is the last step of the process. It's the bit that we're on at the moment, is trying to make that so it's a fully usable interface. So that's very much a mock-up that you've got on the screen there. But we'll go through lots of testing with Chris's team, and we'll make sure that the deployment of this is not just kind of us pushing it over the wall at the leakage team, but very much kind of teaching them, showing them how to use it, and getting as much feedback as we can to make sure it embeds. And I think that's everything. So thank you very much for listening. And if you've got any questions.
Thank you very much, Willow, and thank you,